Hello, Reagan Roadrunners, and welcome to your second super musical lesson from Mr. Peterman. Today we are going to be learning about pitch, which I would say is probably one of, if I were to boil all music down to four main things, I would say those things would be the beat, rhythm, which you guys worked on last time, pitch, and expressiveness. Now, we've only just scratched the surface on beat and rhythm, and we'll get back to them at some point. But today we're going to scratch the surface on pitch. And we are going to be learning about pitch using the scientific method. Now I know what you're thinking, but Mr. Peterman, this is music class. Well, it turns out science is how we learn about everything in our environment, including sound and therefore music. Now let's put on our science glasses and get to work. Now, scientifically speaking, all sound is vibration. So here's my speaker and all my little vibrations out here. And pitch, briefly defined, is the high and low sounds. So what changes is the vibration. So if it vibrates faster, if we add more of these lines and it's vibrating really fast, then we would say it's got like a really fast wavelength and it would look like that. And it would be a high sound. Whereas if it had less vibrations, if it was vibrating slower, then it would be a longer wavelength like this, and it would be a lower sound. And even you can prove that all sound is vibration just by feeling your own voice. So down here, your vocal cords, which are actually more like vocal flaps, and technically called vocal folds, you can feel them vibrating every time that you speak or sing. La. So go ahead and try that. Feel that in your voice. You can feel the vibration. Something else that's pretty cool is that when you make a high voice, you can feel a faster tingle or a faster vibration. Ah. Versus a lower voice, you can feel kind of a slower tingle or a lower slower vibration. Oh. So to help me demonstrate the different pitches, I've got with me this instrument here, the xylophone, and I wonder if you can tell, before I even tell you, what the difference is between, say, this bar over here and this bar over here. So hopefully you can see right away that they're different sizes. If I move it over here, over there we go. So this bar is obviously bigger than this bar, and I can show you by putting one on top of the other. Much smaller. There we go. What do you think is going to be the difference in sound? You got your guess? Here we go. And were you correct? Either way, you're okay, even if you were wrong. We just conducted the scientific method. We took our question, what is pitch? And we did our background research, what is sound? We figured out, we talked about it being vibration. And then we're actually doing our research right now is what I'm showing you. I had you guys make your own hypothesis, which was what's going to be the difference in the sound between this bar and that bar. You came up with your own guess. I don't know what it was, but we tested it out. I made the sounds. And you listened to the results. And by listening, you were analyzing. And then whether you were right or wrong, we didn't really have a way to re-experiment. But the correct answer between those two is that the bigger one is lower and the smaller one is higher. So we're finding different lows and highs. So now, really quick, we're going to do some more research by conducting this experiment again with a different instrument. This is the glockenspiel, soprano glockenspiel. The whole instrument itself is much smaller, so I wonder if you know what that will mean with the pitch. And then we've got the same kind of concept. This bar is bigger than this bar, as you can see here. Maybe you can't. Maybe you can see now. And I'm going to strike each one. Which one is going to sound higher? Which one's going to sound lower? So make your guess. Here's the experiment. Analyze what you hear. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, that one was really high. That one was a lot lower than the higher one, but still pretty high. I can't even make that sound. So what you need to know is that, generally speaking, bigger instruments make lower sounds. Smaller instruments make higher sounds. And that also applies to an instrument like the guitar. So I have all of these different strings on here, and if I get it really close to the camera, you can see that some are bigger than others. So over here on this side, we've got some strings that are thicker or bigger, and on this side, smaller. So this side should sound lower, this side should sound higher. And we are correct. And then we can actually even make each individual string smaller by putting my finger down here. Then not all of the string will vibrate. So if I put my finger down right here on this string, then only this much of it is vibrating rather than this much of it vibrating, the whole thing. So let me put my finger right there, and then I'm gonna pluck this string. And when I let go, the whole string vibrates, and it's bigger and it's lower. And I can do this. Or this. So getting bigger or smaller. And there are some other things that can affect pitch other than just the size, but that is kind of the biggest indicator. One of them is the shape. So say these are generally about the same size. They should be close in pitch, but they're the same material, but they are a very different shape. And shape can also change the pitch quite a bit. So this one's a lot lower than this one, even though the same material, about the same size, just different shape. Another one, other than size, shape, or material, because if it's two different materials like metal or wood, that could change the pitch, is how tightly it's stretched. So say it's like a string instrument. So I've got a rubber band, all made of the same material. I'm going to use this length, and I'm going to use the same length. So this length. And then if I use the same length, but just stretched a little tighter, it's a lot higher. And now, it is your turn to conduct your own scientific experiment. So, I pass the glasses on to you. Now, I promise this isn't going to be so hard. So, to start, what changes the pitch of a sound? We kind of talked about that. So, it's generally the size, but there are some other factors. So that is our question. Our research was to watch this video, so congratulations, you've already done it. And then your actual first step is really going to be gathering supplies from around your house. So these are going to be some instruments, maybe some things that will make noise. For instance, my desk makes noise. That could be one of my instruments. And then I have to get some other things that are smaller and lighter because I'm going to have to bring them over to that desk in order to conduct the rest of the experiment. You are going to guess, so you're going to gather 3 items, and then you're going to guess which is going to sound lowest, middlest, and highest. But scratch that. You're not going to just guess. You're going to make an educated guess. So you're going to defend yourself with your own thoughts on why that instrument is going to sound the lowest or the most middle or the highest. So generally speaking, we know that this bigger one's lower and smaller, higher. And then you are going to record your experiment. While you are recording your experiment, make sure that you're also listening, because if you're only focusing on recording, you might forget to actually listen and try to decide, was that actually lowest to highest? If not, no worries. So you're just going to, after deciding like that wasn't lowest to highest, you're going to move them into a different order, and you're going to just do it again until you get it to lowest to highest. And then once you have it lowest to highest and that answer is a yes, then you're going to just submit your video. One of the first responses in this Flipgrid is my example of this experiment, so feel free to watch that before doing your own. Good luck, everyone.